Hello. Today's video is about rational functions and vertical asymptotes. Our essential question: how do we determine the vertical asymptotes of a rational function? A rational parent function, you will recall, is f of x equals 1 over x. So if we have a rational function, we're looking at a function where there is an x in the denominator. Vertical asymptotes, or a vertical asymptote, is a vertical line that the graph approaches but never touches. Think MC Hammer, can't touch this. To determine the vertical asymptotes of a rational function, you're going to reduce the function to its lowest terms, and then you're going to set the denominator equal to 0 and solve for x. Each resulting value of x is going to be the location of a vertical asymptote. Go ahead and pause and copy this down, and then we'll continue with some examples. Okay, our first example, we want to determine the vertical asymptotes of f of x equals x squared plus 3x plus 2 divided by x squared minus x minus 20. Our first step for determining the vertical asymptote is going to be to factor the numerator and the denominator, and then we're going to cancel any common factors that they have, if there are any. So step number 1, let's factor our numerator and our denominator. So figure out what my factor pairs of 2 are, 1 and 2. So in the numerator, I have x times x, and then 1 and 2. Notice that 1 and 2 add up to equal 3, and my signs need to be a plus and a plus so that I get a positive 3x in the middle. For my denominator, my factors of 20 are 1 and 20, 2 and 10, 4 and 5. And I'm looking for the pair that will subtract to give me a 1x in the middle, so I'm going to use the 4 and the 5. Because we want a negative 1x, I need my 5 to be negative, the bigger value needs to be negative, and my 4 will be positive. So now that I have it factored, now I'm going to look and see if I can cancel anything. And I put over here a note: remember that to cancel terms in a rational function, the terms must be multiplied, not added or subtracted. So once we have it factored, our terms are being multiplied. And I'll cancel the entire thing if it's exactly like something, if I have something in the numerator and something in the denominator that are exactly the same, I can cancel them. But you'll notice that none of our terms are exactly the same. X plus 1 and x plus 2 are not the same as x plus 4 or x minus 5. So we can't cancel anything. So our next step, according to step 2, is to now take each factor in the denominator, x plus 4 and x minus 5, and set them equal to 0 and solve. So we are going to take x plus 4, set it equal to 0, and solve it. And we're going to take x minus 5, set it equal to 0, and solve it. So to solve this, I'm going to subtract 4. And we get x is equal to negative 4, and to solve the second one, I'm going to add 5 to both sides, and we get x is equal to 5. So we have 2 vertical asymptotes for this particular function. And I'm just going to abbreviate that VA for short. So the function f of x equals x squared plus 3x plus 2 divided by x squared minus x minus 20 as vertical asymptotes at x equals -4 and x equals +5. Go ahead and pause, get this down in your notes, and then we'll continue on with one more example. Okay, let's continue on with our second example. Determine the vertical asymptotes of f of x equals x squared plus 2x minus 3, all divided by x squared minus 5x plus 4. Just like in the previous example, our first step is to factor the numerator and the denominator. So let's go ahead and do that. Factor pairs of 3 are 1 and 3. And so when I factor this, I'm going to have x times x to get my x squared term. 1 times 3 gives me the last term of 3, because we are subtracting 1 minus 3, 3 minus 1 will give us 2. We need a positive 2, so we're going to end up with a plus 3 and a minus 1. And if we check that out, that gives us a positive 2 as our middle term. So the numerator is factored. Now let's factor the denominator. We have x squared minus 5x plus 4. So our factor pairs of 4 are 2 and 2 and 1 and 4. And we need the pair that will combine to give us 5 in the middle. So we're going to use the 1 and the 4. Because we're adding, our signs have to be the same, and we need a -5, so they will both be minuses. And this is where, once we have factored, you'll notice that we have a pair of terms that are the same. So we are going to cancel the common term. So we're going to cancel the x minus 1 and the x minus 1. We can cancel them because they are being multiplied by another term. So we cancel the entire parenthesis, the entire term that's in the parentheses. Okay? Not just a little piece of it. You can't just cancel the x. You got to cancel the entire term. Okay? Once you've canceled those terms, I'm going to make a little note over here. The canceled term will be where the function will have a hole. And we'll talk more about that on a later video. Okay, so now I'm left with, after the function has been reduced, I'm left with x plus 3 over x minus 4. X plus 3 divided by x minus 4. So now the only term that I have in the denominator that I need to set equal to 0 is x minus 4. That particular term will be where I will have a vertical asymptote. So only x minus 4 remains in the denominator. So we will have only one vertical asymptote. So x minus 4 equals 0. I go ahead and solve it. I'm going to add 4 to both sides, and we get x equals 4 is where our vertical asymptote is. Now over here, when we were talking about the hole, what we would do with the whole is we would take x minus 1, set it equal to 0 also, and at x equals 1 we would have a whole. Okay. Right now we're just focusing on vertical asymptotes. We'll talk more about wholes in a couple of days. Alright, go ahead and pause, finish copying this down, and then we will practice with vertical asymptotes in class tomorrow. Have a good evening. Bye.